So if my multiplication problem is 3 times 4, what would the dimensions of my sketch look like? So if I draw a rectangle, Alon, what are the dimensions going to be?
3 and 4.
Great. Yep. Remember, I'm not going to draw all of the tiles in there. I'm just drawing what's called a quick sketch. If you have not put your tiles away, please stop, fold your hands, and look at me because you're making noise on the video. And you're not concentrating on this. So stop what you're doing, fold your hands, and look this way. Thank you. So if our dimensions are 3 times 4, what would the product be? What would the product be, Kira?
The product would be 12.
Agree? So the product is the answer to a multiplication problem. The product is what, everyone? The answer to a multiplication problem. Sorry, you were looking for the answer. All right, so this would be 12. And then if I wanted to find, we're going to do what's called a number string. So remember how number strings work. They go from simpler problems to more difficult ones. So let's say I knew 3 times 4, but I don't know, Lamar, 3 times 8. What changed in the problem, Lamar? Did the 3 change? No, 3 is still there. Did the 4 change? Yeah, it changed to an 8. So if I change the 8, it's kind of like I would have doubled this because 2 4s is 8, right? And you should be thinking back, oh, if I double the factor, that reminds me of one of the rules that we did the very first week of school. And you could be looking in your notebook right now. If one of the factors stays the same, but one of them doubles, if one of the factors doubles, what happens to the product chain? If the factor doubles, the product doubles.
Yes.
There you go. Because it's like I'm doing another 12 here because 4 and 4 is 8. The 3 stayed the same. So you should be looking at this model and noticing, oh yeah, it would just be another rectangle that's the same amount. What do I get when I do 12 times 2? Wait a second, Terry, and I don't know 12 times 2. What do I do when I'm timesing something by 2? And you can be looking over at the multiplication strategies chart to remind yourself, Lucas, what do I do? What's the rule? When I'm timesing by 2, what? No? You could do that, but that's not the rule that I'm thinking of because that's going to take me a long time to get there because that would take me 12 of them. So read this for me. Can you read it? You just double the number. So we're going to take 12 plus 12 because that answer is going to be the same as 12 times 2. So if I'm doing 12 and another 12, give me a thumbs up when you have the answer. You can either do it mentally or jot it down, 12 plus 12. I'm going to wait until I have more thumbs up. Challenge yourself. Don't wait for somebody. Don't wait for somebody else to do the problem. Every single person should be adding 12 plus 12. What do you get, everyone?
24.
I agree. Okay, we're going to take it a step further. This time, we are going to just do, we're not going to double it this time. We're still doing 3s. But this time, what changed, Shane?
What changed?
Yep. What changed from the last problem?
The 8 changed.
The 8 changed to what?
9.
Okay, that means I'm gonna take what I had last time. So last time was 3 by 8. And I'm gonna take just one more group of 3. So it's like this side, Corey, got a little bit longer. It got one group longer. Still a 3 on this side. What is one group of 3? One group of 3 is what, everyone? 3. One group of 3 is what, everyone? 3. So I'm just adding another 3 to my last answer. So this part was still 24, because that's what we got for the last answer. And now I'm doing another group of 3. Give me a thumbs up when you added 3 to 24. 24 plus 3 is what, everyone?
27.
27. So that means now I know 3 times 9 is 27. Remember, a quick sketch does not mean that the length of the sides looks exactly right, because actually we know this amount is bigger than this, but I just made it smaller. But that's okay, because I labeled the dimensions of the sides and the area. So it's a quick sketch. And then I have the equation right here. All right, so we're going to do one more, and then I'm going to switch gears. Now I want to do 3, stay with 3, and we're going to do times 7. What do you think? Where do you want to look at from all of the strings that we did so far, Kiara? Which area do you want to concentrate on? What changed? What stayed the same? Rowan, give me one thing that stayed the same or changed from the last problem or from a different one. What numbers stayed the same?
There's 7 and then 20.
Which factor stayed the same from the last problem? The 3 or the 7? Which one's the same? The 3. There's a 3 here. There's a 3 all the way, actually. So the 3's are staying the same. What happened here, though, Kiara?
It kept on changing with the numbers. It went higher, but then it went lower again.
Ah, so the last problem is actually 2 away from 7, right? But what happened here? It was only 1 away from 8, and we added a group. And then you're right, it went back down again. So instead of looking at the very last problem I did, I'm going to go back to this one, because that one was only 1 away. So go back to when it said multiply by 8. That answer was 24, right? Now I'm going to take away part of that. I'm going to take one group away, one group of 3, because this says 8 groups of 3. This says 7 groups of 3. Multiplication is groups. I have 8 groups of 3 here. I have 8 groups of 3 in this picture, and I want to take one of those groups away so that I have now 7. What would that be? If I take one group away, now instead of adding 3, I'm going to subtract 3 from 24. 24 minus one group of 3 is 24 minus 3. Hudson, what do you end up with? No? 24, unless you can't hold it. Can you hold it? For like 2 more minutes? 24 minus 3? Yep. Agree? What do you want?
It's almost
Okay,
like 10.
if you can.
Yeah, it's okay.
Okay, we're gonna stop, pause there.